is the next topic from measurement instrumentation subject. This is the topic called digital multimeter. So many labs, many industries, many companies, wherever we are dealing with the current and voltage, you want to measure the actual voltage and current. Even in your home, office, everywhere we are using this to measure what is actually current required or required for a particular operation. So that's one of the famous meters called digital multimeter. So how digital multimeter works? So that we are going to discuss in this topic today. So digital multimeter is multimeter. So the name is called multimeter. We can measure voltage, current, resistance at various ranges. For example, we can measure the resistance in ohms, kilo ohms, mega ohms. That's like current. We can measure in milliampere, microampere, milliampere, and ampere. The same way we can measure a voltage also in millivolt or voltage. So we can measure the various range, and by using this meter alone, we can measure voltage, current, and resistance at the same time. So in any circuit, we can measure what is the actual voltage, current, and resistance. Exact value we can measure by using this digital multimeter. And this meter will operate with the help of the power supply. We are going to use a battery power supply. Only by using this battery power supply, this digital multimeter will be works. See, these are the actual components present inside the digital multimeter. Some of the components are attenuator, compensator, attenuator, current to voltage converter, rectifier, constant current source, and we have the many options, input options, and output side options. And finally, the output will be displayed only with the help of converting everything to digital and then decoding into the equal number of counter that will be finally displayed on the digital output. So this is what the components present inside it. So I will explain each components, how it is works, and what is the process behind it for digital multimeter. The first case, this is the probe. One is the positive, other one will be the negative. So we can keep that probe anywhere in the area of the circuit. If you want to measure the resistance across it or voltage across it or current passing through it, we can measure by using this two probe. So now I just want to measure the voltage. For example, first case, I want to measure the voltage that can be connected to here. So there will be attenuator. Attenuator, the function of the attenuator is removing unwanted signals. What are the required signals only taken into account? The remaining everything are being filtered out. So that is attenuator. And there will be a compensating attenuator, which is converting everything. For example, if it is a AC voltage, you want to measure in DC value, you can use a rectifier. So rectifier converting AC into DC. And here there will be a compensating attenuator for rectified circuit. And for measuring it, there will be a requirement of current to voltage converter. If it is connecting everything only to the current, even if you want to measure voltage or even if you want to measure resistance, everything are connected only to the current. So first thing is to be convert current to be voltage. After converting current to the voltage, now the current is passing through the resistance which is connected in parallel. It is shunt resistance that will be converted into a voltage. The same way if you want to measure the resistance, so we can know the value of current, incoming current, then there will be current passed through the particular resistance. There will be we can form the voltage. So we know voltage value, we know current value. From that we can easily calculate the resistance value, that is R equal to V by I. So we are connecting the probe only to the current, it's calculating only the current. The incoming supplies everything current. That can be converted into the corresponding value. And here we have many options, whether you want to display digital value, whether it is a current or voltage or milliampere or microampere or millivolt or anything. We have the many options are there. And finally, the output will be displayed to the digital readout. It required in a digital format. So here process everything are happening, everything on analog. But this is a digital meter. It shows the value everything on digital value. So that will be converted into the digital values. So incoming values are analog. So we have to use analog to digital converter, A to D converter. It converts analog value into digital value. That digital value has been decoded and counter counts. If it is a 10.52, the counter counts that value 10.52 voltage. So that will be displayed on the digital meter. So this is the way we can measure voltage, current and resistance. So this digital multimeter is used widely, and the most advantages we can by using only 1 meter we can measure voltage, current, and resistance, and everything on exact value can be shown by digital multimeter rather than analog meters. So digital meters are widely used. So remaining thing we'll discuss another topic in next week. Thank you so much.